Now remember the dynamics of the theory we learned about this morning. Black holes generate smaller black holes that are subatomic particles that makes plasma dynamics around it. When it gets too much plasma, it starts slowing down, and then it becomes unstable, and it fluffs off some of that plasma and then starts spinning up again. I think we're approaching one of that fluff off part. And I think the sun has done this before. There's another thing that the sun started to do. And this data now, I don't have a scanner while I'm on the road, but I found new data recently. The sun has started to pulse these huge electromagnetic pulse emission. And I wasn't sure about this because I thought maybe it's the cameras that are going berserk on the SOHO probe. But it's not. I looked at the data of the amount of negative ions produced by the sun, and the negative ions production is going through the roof right now when these pulses are occurring. It's the negative ion production is at normal on a scale from 1 to 9 when it's at about 2 to 3. And recently it's of the sun all of a sudden just pulsing like this. Let me show you what it looks like on telemetry. See, you gotta know, you gotta go frame by frame, otherwise you can't tell. But if you go frame by frame, can you see that? And then the next pulse. Well, this is days apart. Actually, let me see. See, the camera is taking pictures every few hours. But the thing is that the camera only takes picture every few hours, and if you're lucky, it's going to take the picture of the pulse. But it might have missed a lot of pulse in between. So you don't know, but at least you see some of them there.
How long do you think they last? A second?
I don't know. I haven't got enough data to tell, but it's definitely significant. And the amount, and Elizabeth Rauscher and I are actually right now trying to calculate how much energy it would take for the sun to actually do that. Because when you're talking about an object the size of the sun, all of a sudden changing its amount of radiation, almost doubling it in X-ray, you know, just like that, you're talking about a lot of energy.
Is this an accepted phenomenon? Other people see this and they accept this as something happening?
Well, there's definitely a lot of physicists saying there's something happening about the sun. They're not necessarily all aware of this. I've made many of them aware of it, and I've shown them the data. They don't have much to say about it. They don't know what it is. It's definitely not normal, meaning we haven't observed this from the sun before. I have another one that's much more outrageous. You guys want to see it?
Yeah. Why can't we feel it now? I mean, why don't we feel it when we're outside?
Oh, you do?
You could even see it.
Have you noticed this summer?
Really hot.
The world has never seen heat like this. All around the world, thousands of people have died in Europe. China had 126 degree heat. You know, this is not the result of global warming. Global warming does not happen that fast. Okay? this is the result of something much more dramatic, like the sun going berserk. The other thing is that Jupiter, you see, have you heard about Aurora Borealis this year?
Yeah.
You know what Aurora Borealis are, right?
Yeah.
These colors you see in the sky? These colors you see in the sky are the result of the ions thrown out by the sun, the plasma thrown out of the sun, getting caught in the magnetic field of the Earth, and then getting funneled at the north and south pole of the Earth. And when they enter the atmosphere of the Earth, they create all this radiation that looks like Aurora Borealis. Well, that happens on the other planets too. Let me show you Aurora Borealis on Saturn. See? That's Aurora Borealis on Saturn, on the north and south pole. Let me show you Aurora Borealis on Jupiter.
Have you used any?
These are the pictures of the north and south pole of Jupiter.
Is that unusual?
Well, what's unusual, and I don't have a picture, I gotta get it from the net. I gotta get that in my presentation. What's unusual is that on Jupiter right now, there is so much activity from the sun. Well, on the Earth, never mind Jupiter, the Aurora Borealis are now spanning all the way down to the equator. And they've been seeing Aurora Borealis on the border of Mexico and so on. And there is Aurora Borealis in the North Pole that have been going on steady for weeks and months. They're not going away. Because there's so much solar activity, the sun is throwing out so much stuff that there's so much ions coming in the atmosphere that it's creating these Aurora Borealis all around that are, in a steady state now. But on Jupiter, they have now observed an extremely hot spot, almost the size of the Earth, on the North Pole of Jupiter. Because there's so much solar activity, and all these hot ions are going in, the surface of Jupiter is actually starting to ignite. Jupiter is the exact same composition as the Sun. In the sixth sun tradition of the Incas, the Mayans, and many others, many tradition talks about at the next evolution there will be two suns. And from these tradition, what's his name? Arthur C. Clarke did the movie 2010, where Jupiter atmosphere ignite into a sun. It's the birth of a new sun. I thought that's interesting. But I wanted to show you some of these pulses. I have new ones that are kind of mind-boggling. I hope I can find them. It's kind of not obvious because there's so much stuff going on. Let me see. What pulse is that? So these pulse, is typical or what would be expected of a system that's about to go and release some of its energy. Now, it might not. Okay, 25, 148. Let me see. 25, 148. Let's see. I can nail this.